Hey everyone, in this video I'll be giving a walkthrough of a project I have been working on, Vidora, a safe and spam-free video conferencing platform that integrates real-time AI moderation. The idea behind Vidora is to address a common issue in online meetings, that is unsafe or spammy chat interactions. Most video conferencing tools don't actively filter messages for toxicity, spam, or rapid flooding. Vidora solves this by combining multi-layer moderation, smart filtering techniques, and WebRTC based video calling to create a cleaner or more controlled meeting environment. This is the landing page of the Vidora. We can see some options like login register or join as guest. So now let's get started. Now before entering to the main dashboard page, we need to log in or sign up. So here I am creating a new account. Hit sign up button. So here for the authentication system, I have implemented JWT based authentication layer, which uses a secure password hashing with bcrypt and token based session validation so that the user's identity and meeting access remains reliable. So now the user is registered, so we can enter the password and log in. We are on the main dashboard page. From here, we can join an existing meeting if we have the meeting ID or create a new meeting. Also, on the top right corner, we have options to log out and option to see the previous meeting history. Let's create a new meeting. So go to the host tab, and here we have two modes. One is the normal mode, which is a simple video meeting with no safety or spam restrictions. It behaves like a standard WebRTC room. And another one is spam restricted mode. In this mode, it activates the full anti spam and safety pipeline, which includes message filtering, AI based toxicity checks, rate limiting, profanity detection, and automated moderation. So instead of showing the normal mode, I am directly creating the meeting in restricted mode. So I am selecting here the spam restricted mode and click on the host meeting. So the meeting room is successfully created and the unique room link is generated. So we can share this link with someone we want to talk. For now, I am copying this link and we will open it in new window. So let's copy the link and open it in new window. So yes, now let's join the meet. Let's join the meet with the host ID also. Allow microphone and camera access. And let's enter to the room. So now we are on the call. I can see myself right here and the other person on the bigger screen. So suppose if there are more number of peoples, so the screen will automatically adjust to show the videos of all the members. So just like any other video calling platform, we have the essential controls here: video toggle, microphone on off, hang up button, screen sharing, and yes, the chat section. So let's directly jump to the core feature of Vidora, that is the chat section. Now let's check one by one how Vidora detects and handles different type of spam and vulgarity in real time. So let me start by trying to spam the chat. So as you can see, Vidora immediately detects the high message frequency and shows a warning. Since there's a 10-second window with a maximum of 3 messages, exceeding that triggers a temporary cooldown. During this cooldown, the user simply cannot send messages. Internally, this is handled by tracking per user timestamps on the server side and enforcing a custom rate limiting logic over sockets. Now I'll try sending the same message multiple times. So as you can see here, Vidora blocks exact duplicate messages to prevent the copy paste spam. So now I'll try to send the similar messages that is not exactly same, but they will be similar. So even if the message is slightly modified, Vidora still detects it as a spam. So this is done using string similarity checks. So near duplicate messages don't bypass the system. Now I am going to try to send the vulgar messages. So as you can see, any offensive or vulgar words are blocked instantly using a profanity filter. So on the top of rule-based filters, Vidora also uses Google Perspective API, which analyzes messages for toxicity, insults, threats, and spam using NLP. One more important thing is visible feedback. The user always get a clear alert explaining why the message was blocked instead of silently failing. So instead of relying on just one filter, Vidora combines multiple independent checks like rate limiting, string similarity, profanity filtering, and AI moderation to create a clean and spam-free chat experience in real time. Let's see the system architecture and workflow for the platform. So here we have multiple users, including the host and participants, all interacting through a React-based frontend. This frontend is responsible for the UI, meeting controls, chat interface, and state management. So when a user logs in or signs up, the request goes to the backend server and a JWT session token is issued. This token is used to validate all protected actions like creating or joining a meeting. For the real-time communication, Vidora uses WebRTC. WebRTC handles peer-to-peer audio and video streaming, which means the actual media does not pass through the server, only the signaling does. This keeps the system fast and scalable. The signaling itself is handled by Socket.io, both on the client and server side. Socket.io manages events like joining a room, leaving a room, sending messages, and broadcasting updates to all the participants. Now, whenever a chat message is sent, it first goes to the backend server through Socket.io layer, and here the message passes through multiple moderation checks, rate limiting, profanity filtering, fuzzy similarity matching, bad word detection. Along with these rule-based checks, the message content is also sent to the Google Perspective API, which returns the score like toxicity score, insult score, spam score, profanity score. Based on these scores and predefined thresholds, the server decides whether the message is safe to broadcast or should be blocked. If the message is valid, it is broadcast to all the connected user in real time. If not, the user will get immediate feedback in UI such as warnings or cooldown alerts. Here, Mongo database is used to store the user data and meeting history. So that's all about Vidora. The code is available on my GitHub if you want to see the implementation details. Thanks for watching.